Hi there, in this video I'm going to introduce you to something called the discriminant. Our intention is to be able to determine the nature of roots of a quadratic, and I'll explain what that means on the next slide or so. So for any quadratic, a quadratic is anything written in the form ax squared plus bx plus c. We can calculate b squared minus 4ac, which is the discriminant. Whatever its value is helps us determine what the nature of the roots are, and there are three possible scenarios which I'll show you on a slide in the next picture. It's basically, we'll be using a wee bit of substitution. This could be the first time you've seen this expression here is ax squared plus bx plus c. It's basically a trinomial, and a is whatever's in front of the x squared, b is whatever's in front of the x, and c is whatever's left at the end. If you've already done the quadratic formula, you may have seen this, but you could also be teaching this before the quadratic formula. So literally what we do is we take the values of a, b and c and we put it into this equation here. And whatever the value comes out as determines the nature of the roots. Now, you may or may not have heard about roots of an equation before, depending on what order your teacher's doing quadratics in. Okay, so this here is your most basic quadratic. So y equals x squared looks like this if we were to draw it on a graph. Y equals negative x squared looks like that. So it's just a mirror image of it. Now, as we start to change that equation, if I maybe added plus 3 onto the end, this one would be y equals x squared plus 3, and I've moved it up 3 places. One over here would be maybe putting it into trinomial of x squared minus something x plus a number. I've moved it all over the place. Now, you've heard me mention the word roots already in the previous slide. A wee reminder that roots are wherever this graph cuts the x-axis. So this one here has 2 roots. Okay, we've got 2 places where it cuts the x-axis. This one here has got 1 root. It's actually called a one real root repeated. And then this one up here, does not cut the x-axis at all. So it's got no roots. Okay, no real roots. So I'm going to put this into a good wee thing that I'd like to copy down into your notes if you're doing that. So here are all your scenarios. If your answer comes out as less than 0, so when we do our substitution into the formula of b squared minus 4ac, we maybe come out with a number like negative 3, negative 4. Because your discriminant is less than 0, we say that this has no real roots. Okay? So we say it's got no real roots. And that's what it looks like graphically. It's one that's been moved up or something like that. On this second one, if you come out with an answer of exactly 0, that means it has got 1 real root repeated. And if you've been taught factorising already, that's when you come out with a factorised trinomial of a repeated root, like x minus 3 in the brackets. So it's got 1 real root repeated, and that's the one that's just sitting, touching the x-axis. And then if you come out with an answer of your discriminant being greater than 0, that's this third scenario here where there are 2 clear, distinct roots on the x-axis. So there's a lot to take in here. Less than 0, no roots. Equal to 0, repeated roots. Greater than 0, 2 real and distinct roots. Okay, and these definitions here, I've seen my writing in blue, these definitions are really important because you have to write that at the end to make sure you get the mark. This is what they're looking for. Okay, so you must write the definitions exactly. So I'm going to do 3 examples. It's pretty obvious I'm going to do 1 of each. So let's have a look at it. So it says determine the nature of the roots of this equation here. The first thing I'm going to do at the side is I'm going to write down what a, b and c are. So a is the number in front of the x, which is in front of the x squared, which is 2. B is the middle term, which is a 4. And C is the number over here, the end value, which is 5. Then we're going to work out what b squared minus 4ac is. So b squared will be 4 squared. Take away 4 times 2 times 5. And again, I put in brackets. You could write multiplication signs in there if you wanted to. So let's work this out. 4 squared is 16. 4 times 2 times 5 is 40. 16 take away 40 is negative 24. So we've got a negative value. So negative was the one where it looked like that and there was no real roots at all. So our conclusion is b squared minus 4ac is less than 0, so no real roots. Okay, so that was the first scenario I showed you. And that's all you're doing. You're doing substitution. And the hardest bit is making sure you put your A, B and C in correctly. Look out for negatives as well, and just watch silly things like your basics of adding and taking away. And the conclusion is very important. Let's look at my second one. So determine the nature of roots for this one. So again, I'm going to write down A is the number in front of the x squared, which is 7. B is the middle term, which is 5. And C is the end term, which is -1. Please be careful. If there's a negative in front, you have to include that as well. B squared minus 4ac, our discriminant, gives us B squared is 5 squared. You could choose to go straight to writing 25 there if you wanted. Take away 4 times 7 times -1. So 5 squared is 25. -4 times the -1 will turn into a positive. Oh, I shouldn't have put that squared there on the 25. So it's 25, that turns into positive. 4 times 7 times 1 is 28. 25 add 28 is 53. So in this case, we've come out with b squared minus 4ac was greater than 0. And greater than 0 was the scenario that looked like this, where we had 2 roots. So we have 2 real and distinct roots. You have to make sure you have the words real and distinct in there, or you won't get the full marks, I'm afraid, in the exam or in a test. So it's got 2 real and distinct roots. One last example. Let's go to the side again. So A in this case, there's no number there, so that's really a number 1. B is 6 and C is 9. So b squared minus 4ac. B squared is 6 squared minus 4 times 1 times 9, which gives us 36. Take away 36, which is exactly 0. So because b squared minus 4ac equals 0, that was the one like this, where it sat on the x-axis. Now this one actually looks like this. So we say it has 1 real repeated root. Excuse my writing. So it's 1 real and repeated root. Now if you were to explain what that means, if you were to go and factorise this trinomial up here, that would give you x plus 3 in the brackets. So because it's giving you repeated factors, that's what it means by a repeated roots. And if you're doing this lesson after having already seen solving quadratics, you would know that that gives you x equals minus 3, x equals minus 3. And in fact, the roots of this equation both are here sitting at minus 3. And obviously that should look like it's sitting on the axis. Okay, so hopefully you followed those 3 examples. Just remember, what we are doing here is just substitution, okay? And remember to use the formula remember you're using the formula ax squared bx plus c to help you figure out where your a, b's and c's are. But it's pretty much in order: first term, middle term, end term. So for each of these questions, pause the video, try these. For each one, you're going to work out what b squared minus 4ac is. Depending on your answer, will change your statement. Just watch out for this wee one in here. Example C. It's not in the normal layout. So personally for that one, I would rearrange that one and write it as negative 2w squared, negative 5w plus 3, if that helps any. Okay, and if you want to pause the video, try these. The answers are on the next slide as well. So there are your answers and your statements. I hope you followed this video okay. Best of luck.